Support for Consider This is provided by the University of Nebraska at Omaha College of Communication, Fine Arts, and Media.
From the campus of the University of Nebraska at Omaha. Consider This, a program of issues and information behind today's news.
.3D printing is a technology that lets you take a digital file and turn it into a physical product.
3D printing is this amazing new technology where you can take a 3D digital file and with the click of a button use that file to create an actual physical 3D part.
Hi everyone, I'm Kathy Wyatt. Welcome to this week's edition of Consider This. Our topic, 3D printing. Here to talk more about it are Dr. Tyler Scher. Dr. Scher is a licensing associate at Unimed and co-founder of UNMC Makers 3D printing organization. Dr. Jorge Zuniga. Dr. Zuniga is in the Department of Biomechanics at UNO. His specialty is 3D printed prosthetic, orthotic, and assistive devices. And then seated next to him is one of his students, James Pierce. Thank you all so much for being here and welcome to the program.
Thank you. Thanks for having us on.
There you go. You are very welcome. Let's start off. What is 3D printing?
Yeah, great question. So 3D printing is an additive manufacturing process where you take a computer design of a 3D object and convert that into an actual physical three-dimensional object. 3D printers are amazing machines, very similar to how inkjet printers replace the need for a whole assembly process of printing, manufacturing paper and books. 3D printers actually replace the need in some respects for a traditional assembly line process.
I was going to ask you the evolution of printing technology. I mean, this is pretty interesting stuff we're going to be talking about today. Where have we been to get to where we are now?
It's a great question. Yeah, so 3D printers, 3D printing technology was invented really by an engineer, Chuck Hull, in the 1980s. So he's also the co-founder of 3D Systems, which is a major player still in 3D printing and 3D scanning technology. The first commercially available printers came on the market in maybe the late 80s, early 90s. But it's really been in the last decade or so that 3D printing technology has just exploded. And that's coincided with the expiration of some of those original patents actually around 3D printing, which has allowed competition to enter the marketplace.
Okay, so interestingly, how did you become involved in all of this, Dr. Scher?
So I'm really interested in technology. Always have been, just love technology, love innovation. And during my graduate work at the Med Center, I was kind of keeping a finger to the pulse of 3D printing. And came across an ad for this commercially available 3D printer and was surprised to see it was only a few $1,000s. This was about 5 years ago. Mm-hmm. They're even cheaper now. And so, much to my amazement, I thought this technology was still astronomically expensive. So I was really surprised and excited, and then especially in thinking about how it could be used at a research hospital, how it could be used to drive innovation, the development of new medical devices and research tools. So my initial involvement was actually, it sort of became an obsession of mine for about 6 to 9 months, where I went around just trying to find where in the Med Center I could find the money and the space to house 3D printers that would be accessible for students, staff, and faculty. And eventually found a home in the Library of Medicine, and eventually helped create the Makerspace.
That's no small undertaking. Talk about the journey to get all of that. I mean, you say it in 30 seconds like it's really no big deal, but there had to have been some serious legwork involved in that.
Well, and a lot of help along the way too. So I had help from student senators, I had help from the Graduate Student Association, I had help from vice chancellors and support from a lot of people, and ultimately a lot of support from the director of the library, Emily McElroy. She was very much behind the whole initiative. Much to the chagrin of my research mentor at the time, I was still working on my thesis, but also kind of tangentially also really involved in getting this makerspace created.
Put this in perspective for us. You said you've always been interested in technology. Was there one point in your life that you can remember, waking up and thinking, this is what I'm going to do, for the
Yeah.
rest of my life. And what was that for you?
Yeah, it's a great question. I don't know that I can really think back on one point. I've always just been interested in the application of science towards human health. So, and I don't exactly remember when that passion kind of took root. I know in undergrad, for example, I was interested in doing research, and I got involved in doing biomedical research at Madonna in Lincoln at the rehab hospital.
sure,
Actually,
sure.
had a great opportunity there as well through the engineering program at UNL. But was always just kind of interested in helping people first and foremost, and science and technology has delivered great innovations for doing that, and 3D printing is one of them.
Well, and so let's talk just a little bit more about the uses for all this. I'm still just trying to get my arms around the whole idea of it, especially when you watch the opening video, for example. So what in your world are you seeing as probably the most popular, most commonly used purposes for this?
Sure, yeah. So 3D printing's really invaded basically all industry at this point. So it's being used in some of your kind of more traditional manufacturing and engineering applications like automobile, aeronautics. Also being used in maybe industries you wouldn't expect, clothing, jewelry, shoes. It's being used in architecture. In my world, though, in the healthcare realm and medicine, 3D printing has yielded some great applications. So one would be preoperative planning. So you're probably familiar with the process of converting actual patient medical images into physical objects for surgeons to practice on, to hone their skills before going into surgery. And our good friend Gabe Linke actually coordinates that process at the Children's Hospital here in Omaha. Another big application for us at Unimed especially, our inventors will use 3D printing in order to actually rapid prototype their medical device concepts or research tool concepts. So they have a design, they maybe start with a napkin drawing, and very quickly, because of the use of 3D printing, we can turn that into a 3D file and a physical object that they can test and improve and iterate on, to then be able to have an actual physical object that's been tested, tried, proven, to then take to the marketplace.
Fascinating. And then Dr. Zuniga, there's the department, biomechanics, which I know we've addressed that topic on this program before, but for those people who didn't get a chance to see it, tell us about your world.
Well, basically what biomechanics is a combination between human movement and physics and mathematics. It's a combination, and specifically we study human movement. And within the human movement, we have a laboratory where we develop artificial limbs. So not only that, but a lot of different assistive devices with the aim of helping people in general. So our focus is identify the problems with people and help them to restore movement.
That is very cool. Now, you've been open for a while. Talk to us about what's transpired in biomechanics, specifically in your world since you opened. I mean, what's happened there?
Well, what's happening, a lot of different things. We have improved our technology, so now we're buying all kinds of machines to manufacture our own devices. We're also inventing new methods to diagnose different type of movement disorders. There is explosion of inventions of devices that would help people move again, especially those with some problems and dysfunctions of movement. So
yeah, all eyes are on you, which is actually kind of nice when it comes to putting in a grant application for something that is very necessary, and obviously you have a lot of that in your realm. Talk to us about the grant that got you started with all of this, and while you're doing that, we're going to put up some video if that's okay. Yeah.
Absolutely. So basically, we got $150,000 from funding from the state of Nebraska. Basically, it's the University of Nebraska system. This grant is basically to support the development of the next generation of 3D printed prostheses. So the way how we're doing this, we're basically lowering the cost of prosthetic devices or artificial limbs, as you can see there in the video, and trying to study how children use these devices. And we're lowering the cost to a fraction of what they usually are, and making these prosthetic devices available to everybody in the world. So that's what most people don't know, is that here in Nebraska, we developed the first open source 3D printed prosthesis in the United States. So we beat Harvard and we beat MIT and we developed the first one. And that hand prosthesis, which is called CyberBeam, is being used by people around the world.
I know this might sound trite, but honestly, how does that make you feel? That's pretty darn
That's
cool to think
absolutely
about.
fantastic. You know, that's who we are. So people here in Nebraska, the scientists in Nebraska are top quality. We're second to none, and that's something that we need to understand and we need to recognize.
Yeah.
Our scientists here in the state of Nebraska, in the University of Nebraska system, are top quality. So absolutely, we feel fantastic, and this is amazing. You have no idea the emails that we get, pictures of children that have restored their movement. Now they can move and they can hold objects and from all over the world. It's absolutely fantastic. We're super happy about that.
Well, congratulations. And I know we've talked about the children, but tell us, broad strokes, what are we talking in terms of that population? And as you were really drilling down in that grant app.
Well, what really happens is that prosthetic devices are extremely expensive. And believe it or not, insurance sometimes don't cover it. So we have a lot of children, and here in Nebraska, here in Omaha, that do not have access to an artificial limb because mom and dad and the families don't have money to pay. We think that's absolutely unacceptable. And therefore, we decided to develop a product that's open source and also something that people can access very cheaply. So to give you an example, the prosthetic devices we develop, we can do it for about $50 as compared to $50,000 or $20,000 as the standard prosthetic devices. So you can see how disruptive this technology is.
Wow, so the question then becomes that's a pretty startling stat. You just mentioned there, how do these kids then and their families learn about what you're doing? Is there an application process? I mean, talk to us about the process involved with someone needing this and then being paired up or partnered with you.
Where typically what happens, they usually, we have a lot of publications in the scientific world, so most of rehabilitation hospitals around the Midwest and around the world, including South America and other places, they know about us. They already know, so we have a lot of demand. We have hundreds and hundreds of people that contact us in a weekly basis. So they know because of their medical institutions.
Yeah. So the alternative then, let's say they call. It sounds like you have a lot of folks very, very well aware, which is fantastic. Able to help everybody?
We usually we develop a technology that allow us to fit this prosthesis at a distance. So with a single picture, with the cell phone picture, we take that picture, we take several measurements, and we can develop a prosthesis that would fit them perfectly. So we developed the prosthesis here in Nebraska, Omaha, Nebraska, UNO, and then we ship it around the world. And we contact the medical institutions associated to this, and they can use it. So we provide now this cost, basically this is at no cost. We gather data so to show insurance companies that this is a technology that's valid, and hopefully they can pay for that and allow most people in the United States to access this type of technology.
That is incredible. Okay, you're holding something there in your lap. I'm going to ask you to hold it up just, level here, so maybe we can have a camera take a nice picture of it for a little bit here. Walk us through this device.
Oh, this is just a simple prototype. We call it hybrid prototype. As you can see, it's made out of plastic. By the way, this plastic is eco-friendly. It's made out of corn starch, so it's very low cost and accessible here in Nebraska, of course. And the cost of this is about $150. And this, when we flex the elbow, it closes. We also have an electronic system component that wirelessly reads the electricity from the muscles and help the child grab objects and do this motion here. So if they have some sort of weakness in the elbow and they cannot flex it, well, no problem. We have this sort of system, electronic system that with a wireless connection helps the child grab an object and do simple tasks, and has some wrist adjustments and all kinds of little gadgets. So this is one of the devices we have developed for this grant.
I'll be darned. I want to put a face to all of this. We have a photo of a child. I think it's nice to put it all together, and we're going to go ahead and put that up and talk about that a little bit in terms of what you just described and how it actually works. So I want to do kind of the before and after. You have that child who needs your help in order to be able to do the things that you just described here. Can you think of someone in your mind now and take us from start to finish with that child, right? So
absolutely. So a good example would be a child that we have in Chile. So he's a 5-year-old child, and he lost his arm by an accident, and he contacted us, and we basically, the mom and dad sent us a picture with their cell phone, a single picture. We got the picture, and within a week we were able to gather the measurements and build the design that would fit this child perfectly. So it's symmetrical. It's a device that the child can design basically himself. He tells us what colors he wants, or if he wants his name somewhere else, or if he wants lights or laser shooters or whatever he wants, we'll do for him. And within 1 or 2 weeks, we take this device and we send them to his residence, and where he can use it and do some sort of activities.
Thank you. James, I'd ask how you became interested in all this, but I'm interested in it now, and this isn't even my area. Fascinating stuff. You're a grad student.
Yes.
Correct?
Yes, just about to finish up the second year here.
Okay, so in a nutshell, before we go into specifics here, what's important to know about James Pierce?
Well, so my background coming into the program was mechanical engineering. I actually got my undergraduate degree in Minnesota, where I grew up, and came out here for work in 3D printing, funny enough. After about 2 weeks of working at that job, I came across Dr. Zuniga, reached out, and I've been working with him ever since. So after a couple of years, opportunity arose to come to UNO and study under him in the biomechanics department, and it seemed like a no-brainer. It was the step that took the engineering aspects of what I really loved and added in the human element, and it's been amazing to have that.
So who inspired you in that world growing up? When did you know that that's what you wanted to do?
Well, my dad growing up really fostered a love of science. So ever since I was maybe 3 years old, I was designing rocket bikes and things like that. And I always knew that I wanted to build something, that I wanted to make things that would help people. And that just kind of carried through into college, where I did a lot with 3D printing, just because the technology was so emergent and new and interesting. And it continued after into working in the aerospace industry, and then working locally in Omaha. And yeah, after a long time of just working in engineering, that human element kind of continued popping up and nagging at me. So the draw to design parts for jet fighters and things like that kind of got to be less appealing, and making hands for kids in need got to be a little bit more interesting to me.
Did you do much of that, James, in your previous life in terms of outreach and helping others? Is that something that just kind of came along and partnered with this, or has that always just been a passion of yours as well, and you were able to find a match here?
So funny enough, growing up, I never really, well, I had my little brother and I cared for him a lot, but aside from that, I didn't really reach out to the community too much or anything. It was, I pretty much had to work to put myself through school and everything, so that kept me busy. But once I got that economic freedom after graduating and moved into the industry, then that community outreach, community service side kind of grew over time. And now I'm proud to say that I'm able to contribute to prosthetic designs and prosthetic productions for children all over the world.
Well, Dr. Zuniga gave us a great story. I'm sure you have a few to tell. I mean, when you're out and about and people ask you what you do, whose face comes to mind for you, and what is it that continues to push you forward in doing what you're doing with biomechanics?
Oh, for me, probably the biggest drive to continue innovating and continue working towards our goals has to be not any one kid that we worked with in particular. It's that reaction that we get from every single child that we have come in. Every time, these are children who haven't really gotten to use prosthetics before because, as Dr. Zuniga mentioned, the price is so prohibitive, people can't afford it, and insurance won't pay for it a lot of the time. So these kids go from being just kind of sad about the overall situation and just not very excited to just having their faces light up the second that they get these prosthetics on and start using them. So it's that excitement that they get that really drives me forward.
Well, you bring up such a good point, and I'm glad we're talking really about the story behind some of these kids. You go through a life-changing event, which is what they're doing, and then you're told, no, sorry, that's just not going to be possible. That's a double whammy, and some kids likely will not rebound from that. So the fact that you're able to do what you're doing and help those kids. And I also want to ask James, especially of you as the grad student, the whole international connection. Dr. Zuniga was talking about helping kids all over the world. I mean, you're taking something here in Nebraska and you're sharing it with kids you'll never meet. You'll never really know. Talk about those experiences in terms of how you're feeling about what you're doing now and where you're headed.
Well, it's really amazing to be able to take something local like we have here and apply it worldwide. Our collaborations are growing all of the time. We actually have associated institutions all over the world now, and it's amazing to be able to take, as Dr. Zuniga said, a single picture of an amputated limb, develop a prosthetic, send it in the mail, and then a couple weeks later either get we've had amazing videos from subjects at a distance of just them putting on the prosthetic and instantly being able to pick up things and play with toys and everything, and it's amazing. But even just hearing from people in other areas where that's not as much of a possibility, hearing back the news through email or just snail mail of how well the prosthetics are working, that feedback is always a continual drive forward, and it continues pushing us to improve the designs as well.
Well, one of the things I'm thinking about is you're sharing that information, especially with all the technology and not physically ever getting to sit down with these folks, the instruction piece. So you ship this to a child and his or her family, right? And you hope that there are folks around who can help. But how does the training piece work, Dr.
Thank
Zuniga?
you so much for asking that. So that's the beauty of this design. We designed something that is extremely simple to use. So typically for the normal prosthesis, the ones that are very expensive, it requires a long sessions of training to get used to the prosthesis. There is a harness I have to put on and regulate the cable tension and trying to do certain movements to make the prosthesis work. Well, we thought that was a little bit of nonsense. We're biomechanics, right? We're biomechanics. We can do things that nobody else can do. So we put our minds together and decided to do something that's child-friendly. Not only they can use it, it takes 30 seconds for them to learn how to use these devices. I'm not lying, 30 seconds. And on top of it, they can put it themselves. They don't need any help because most of our devices go to 6 to 8 years old children, and they don't want help from anybody. I don't know if you know any 6-year-old, but they don't want help from anybody.
They're fine, thank you very much, yes.
They want to do it by themselves.
Yes.
So we did this thinking about them. So I have children that age, so I know them very well. So they can put it on themselves in less than a minute, and within the next 30 seconds, we ask them to flex their elbow, which most of us can do without problem, and then they learn how to use this prosthesis. So yeah, instructions are very simple. We actually send them 1 page instructions.
That's impressive. Dr. Scherer, in the minute we have remaining, what is the future of all of this looking like?
Yeah, it's a great question. Actually, one of the most exciting applications for me, in my mind, is actually combining this awesome technology, 3D printing, with biology, with what we're doing with medical advances into bioprinting, actually. So now we're talking printing with actual living cells, and we're talking about actual printing tissues, printing whole organs, so totally changing the game in terms of organ donation. And it's maybe still a little pie in the sky, but I think it's entirely possible that within my lifetime I'll be able to go into a hospital, have some of my cells possibly removed, proliferated, and 3D printed into a new kidney or heart for me.
Wow. That is just wow. I hope you see that. I really do. I want to put up a couple of websites because I'm sure our viewers are pretty interested in this and wanting to learn more. So if they go to unimed.com, they'll find some information there, or I guess they can go to unomaha.edu, and once you get there, you search biomechanics or cyborg beast. Gentlemen, I want to thank you so much for being here today to share your time and expertise. This is really fascinating stuff. I wish you very well with the grant and things moving forward in your world too. Congratulations on all you're doing. Thank you.
Thank you so much.
And I want to thank our students who are working so hard behind the scenes, and of course our viewers for watching. As we close, a look at Heartland of America Park as seen through the lens of Jing Yi Liu, a senior right here at UNO. We'll see you next week.
Consider This is an issues and information program produced by UNO Television. More information and program archives can be found at netnebraska.org/Consider This. If you'd like to share your comments about this program, call UNO Television at 402-554-2516 during regular business hours, or send an email to cwyatt@unomaha.edu.
Support for Consider This is provided by the University of Nebraska at Omaha College of Communication, Fine Arts, and Media.